Dear learners, I am Dr. V. Venkatramanan, Faculty, School of Interdisciplinary and Transdisciplinary Studies, IGNOU. Today, we will be discussing about climate change, part 2. See, these atmospheric aerosols are very fine particles suspended in the air. They are formed by the dispersal of material at the Earth's surface. They are basically called as primary aerosols, or by the reaction of gases in the atmosphere that we call it as secondary aerosols. These atmospheric aerosols include the sulfate particles and nitrate particles from the oxidation process, and that can take place during the process of burning of fossil fuels, the burning of organic materials from the oxidation of volatile organic compounds, and also the soot particles from the fires and mineral dust also from the wind blown processes that is taking place in the desert regions. So these aerosols affect the climate through various ways. It can increase the scattering of the solar radiation, and it can bring in a lot of interaction with the atmospheric gases also, and it can also have an indirect effect of very important process, the cloud formation process. So the cloud condensation, nuclei and everything can be impacted by the atmospheric aerosols. So the atmospheric aerosol, the loading, the concentration present in the atmosphere because of human beings is a very important driver of climate change, anthropogenic driver of climate change. So having said that, how important the human actions, how they've caused a lot of changes in the climate system in the past 2 centuries, and that has led indeed to the increase in the global temperature of 1 degree centigrade. So now when we talk about the drivers, one related concept is the radiative forcing. Let us now study about the radiative forcing as it is related to global warming and climate change. We must know how the various drivers of climate change contribute to climate change, and in fact the quantifying their effects is a great challenge, each and every radiative forcing So however, quite a number of metrics are available to provide estimates of the climate impact of individual factors or the drivers of climate change, individual drivers. We can quantify their effects, their impacts, because we need to understand, because everything is related with the strategies, the portfolio of mitigation and adaptation strategies. So in that way, we need to quantify the effects of each and every forcing factors. So in this context, the concept radiative forcing is very important. The Intergovernmental Panel on Climate Change defines the radiative forcing concept as a measure of influence a given climatic factor as on the amount of downward directed radiant energy impinging upon the Earth's surface. In other words, radiative forcing is the change in the net downward minus upward radiative flux, and it is expressed in terms of watts per meter square at the top of the troposphere, we call it as TOA, or top of the troposphere, or we call it as tropopause. For example, a change in the concentration of the carbon dioxide or output of the sun, each and every drivers we can have the value, radiative forcing values. It is an important tool, it's a very important tool indeed, used to determine the effects that each and every greenhouse gases or aerosols or the clouds have on climate change. A related concept related to radiative forcing, another concept is called effective radiative forcing. This effective radiative forcing is the change in the net top of the atmosphere, downward radiative flux after allowing for atmospheric temperatures, water vapor and clouds to adjust, but with the surface temperature or a portion of surface conditions unchanged. So the total anthropogenic effective radiative forcing over the industrial era, if you look at it, it's around 2.3 watts per meter square. It's a significant amount because that's how the human actions, and we have quantified it. It's coming to the tune of 2.3 watts per meter square. As regards the forcing, the changes that cause a warming effect, we call it as a positive forcing. If it is if it is causing a warming effect, we call it as positive forcing. While the changes that result in a cooling effect, we call it as negative forcing. So the imbalance between the positive and negative forces result in the changes in the Earth's average temperature. It is reported that the net natural forcing, which includes the solar plus the stratospheric aerosols from volcanic eruptions, has been negative over the past possibly 4 decades, 2 to 3 decades. On the other hand, the positive forcing by well mixed greenhouse gases has increased rapidly over the past 4 decades. We know that an average of about 342 watts of solar radiation strikes each square meter. We call that as a solar constant. So any change in the distribution of the radiation within the atmosphere will cause a corresponding rise or fall in the Earth's surface temperature. Okay. So we will see further the forcing compounds. The forcing compounds are grouped based on the common properties. Grouping forcing compounds is very important because it helps us to understand the radiative forcing. Primarily, the forcing compounds are grouped into well-mixed greenhouse gases and near-term climate forces. Well-mixed greenhouse gases are mixed throughout the troposphere, such that few pockets, a few remote observations would suffice to gauge the atmospheric load of the forcing. It's very well properly mixed up, and that's the reason why few pockets, the sampling few pockets will be sufficient, fair enough. Consequently, the global forcing per unit emission and emission metrics for these well mixed greenhouse gases do not depend on the spatial or geographical location of the emission. So the well mixed greenhouse gases include the carbon dioxide, nitrous oxide, methane, the sulfur hexafluoride. They are very popular greenhouse gases, and these are part and parcel of the well mixed greenhouse gases. The anthropogenic increases in the well mixed greenhouse gases have substantially enhanced the greenhouse effect, and the resulting forcing continues to increase because it's a very important thing, that well mixed greenhouse gases, and we'll study in detail in next slide. The near term climate forces are short lived climate forces, or they are called as because climate pollutants. In fact, they are very short lived, and these are the compounds whose impact on climate occurs primarily within the first decade after their emissions. It's a very short lived it's having a very short life in the atmosphere, and these forces are otherwise called as shorter lifetime timers, and they include the methane. It's having a fairly around 10 to 12 years in the atmospheric residue, that time, atmospheric lifetime. The ozone, the aerosols, their action on the climate is near term. So it's a very significant point we need to take into account, because these the short term the climate pollutants we need to manage, because if you through proper mitigation strategies, we can have a drastic effect on controlling the increase in temperature. So it will be a very much part and parcel of the climate policy, the strategies, the mitigation strategies particularly. So now let us now discuss the trends in the greenhouse gases concentration. It's a very important topic because we need to understand that how the greenhouse gases concentration has increased since the Industrial Revolution, because before the Industrial Revolution the concentration level has not has changed not significantly, because the effect was more of driven by the natural processes. But thereafter, when you see since the Industrial Revolution, the impact of human beings are paramount, predominant, and through their uncontrollable human actions, they have caused a lot of changes to the climate system. As I told earlier, through the changing the global concentration, atmospheric concentration of greenhouse gases, land use changes, and so on and so forth. So let us see the greenhouse gas concentration, the trends in it. So the globally average greenhouse gas concentration are found to increase since the onset of industrial revolution. That is a very significant point we need to take into account, and it has been proved beyond doubt. So the increases in the greenhouse gases are responsible for increasing the surface temperature, and it is again proved because the increase in surface temperature, whatever in the last century, 2 centuries, if you see, to 1 degree centigrade, it has increased to 1 degree centigrade. It is because of the increase in the greenhouse gases. So now it has been proved beyond doubt that human actions are responsible for causing climate change, and it's a very significant point we need to take into account. And as far as the surface temperatures are concerned, you can see the slide also definitely talks about the global averaged combined land surface temperature and also the sea surface temperature. And more in climate change studies, we normally use the term anomaly to understand how the changes are so rampant, or because in that way we can be very well categorically state that the temperature increase is to that extent. So that's why this is very important thing. One of the visible indicator of warming climate is a sea level rise. It's a visible symptom. So that is a significant point we need to take into account at this juncture. The last report of Intergovernmental Panel on Climate Change, that is a 5th assessment report, states categorically that the globally averaged combined land and ocean sea surface temperature data, it has been calculated, and it's showing a slowly gentle increase in the temperature. And the last year data, if you see, it is in 0.85 degrees centigrade, but last year it has come with the new data which states that the temperature is increase has already crossed 1 degree centigrade. So that is a significant point we need to take into account. So the human actions continue to change the atmospheric composition and increase the concentration of the radiatively active gases. Even if the greenhouse gas concentration is kept at the present level, the Earth's surface temperature is bound to increase by 0.6 degrees centigrade by the end of the century. It's a very significant point. So time is very, very less, short indeed. We need to take a lot of measures to mitigate and also take the adaptation strategies as well. So both mitigation and adaptation strategies has to be taken into account simultaneously, both hand in hand. So then only we can manage the catastrophe of climate change, because this climate change threatens our existence. Our survival is challenged. So that way the portfolio of both mitigation and adaptation strategies should be the visionary, in other words forward looking. So the total greenhouse gas emissions due to generically if you look at it, is around 49 gigatons of carbon dioxide equivalent. The data of it's around the past data is 2010, which states that per year the total greenhouse gas emissions because of the human action is 49 gigatons of carbon dioxide equivalent. So the greenhouse gases emission data are presented in terms of carbon dioxide equivalent, normally we presented in terms of carbon dioxide equivalent based on 100-year global warming potential. The equivalent carbon dioxide emission is defined as the amount of carbon dioxide emission that would cause the same integrated radiative forcing over a given time horizon as an emitted amount of greenhouse gas or a mixture of greenhouse gases. So this carbon dioxide equivalent is the metric we are following it, because that will be in a way we can bring every greenhouse gases, the effects on a same platform. Let us see for our discussion, because the most important greenhouse gases are the carbon dioxide, the nitrous oxide, the methane. These are the very important greenhouse gases. For the simple matter, these three important gases put together amount to 80% of the total radiative forcing, and also their concentration is found to increase since the Industrial Revolution. So the increase in the atmospheric concentration of these three gases are primarily due to fossil fuel combustion, the most important point. The second important point is the land use changes, and the third is the agricultural activity. It is reported that the carbon dioxide concentration in the atmosphere has increased by 40%. 40%, believe me, 40% from 278 parts per million in 1750, that is start of the industrial revolution, to 390, and now it has crossed to 410 parts per million. It's a significant amount. And during the same time interval or some time period, the methane concentration was also increased by 150%. It's a very important thing, 150%. So the value is from 722 parts per billion to 1810 parts per billion. That's the current concentration of methane. It has crossed 1800 parts per billion, but during the industrial revolution it was just 722 parts per billion. It's a very important change. That's why it is 150% has occurred, and this is why, because of human action. Let us see what are the reasons for that. And as regards the nitrous oxide, the increase is to the tune of 20%. Then during industrial revolution it was around 270 parts per billion. Now it has crossed 320 parts per billion. So half of the carbon dioxide emission was sequestered. As far as the carbon dioxide concentration is concerned, half of it has been sequestered in the ocean, and also the vegetation, the vegetation biomass, because the vegetation also, through the process of photosynthesis, it can also sequester the carbon dioxide. And it's a significant contribution, that's carbon sequestration. Not only the vegetation, the soil ecosystem also sequester the carbon dioxide. The soil is rich in the organic carbon, which is the lifeline of agricultural activity, if you look at it, because all the nutrient rich, everything is contributed by the soil ecosystem, because that organic matter present in the soil can provide food to the living organisms. I am talking about the soil microbiota. So the carbon dioxide, half of the amount that we are emitting, or in other words, that is in the atmosphere, it has been sequestered through a natural process of sequestration, whether it is in the vegetation biomass or the ocean body, phytoplanktons in the ocean body, and also the soil ecosystem. See, as regards the increase in the carbon dioxide concentration, we have talked about the main reason is the fossil fuel combustion. And as far as the increase in the methane concentration in the recent past, the causes, if you look at it, are basically the natural wetlands, natural wetlands. They are the main important causes. Thereafter, there are agricultural activity, waste management strategies, and of course fossil fuel related activities also. And these are all the reasons why the methane emission is increasing in the past 2 centuries. The main important activity is, yes, it is agricultural activity. Agricultural activity contributes immensely to the increase in the concentration of methane in the atmosphere. And one more important thing, that is a very significant point indeed, because the biomass burning that is taking place, if you look at it very recently, in the recent past, if you see in the past 2 or 3 decades, if you see, the biomass burning is very rampant all along in the northwestern part of our country. And this biomass burning, of course, there are a lot of drivers for this crop residue burning, but this crop residue burning also releases a lot of greenhouse gases, particularly the methane. So it's a very significant thing. So the next greenhouse gas is the nitrous oxide emission. Yes, nitrous oxide emission are caused mainly because of the microbial activity, microbial mediated nitrification processes and denitrification reactions. And it can occur, these kind of processes occur in the soil and ocean also, but the main drivers, what is that? It is the application of nitrogenous fertilizers. That is the most important reason why the nitrous oxide emission is increasing in the atmosphere. So the agricultural activity contributes immensely for the increase in the concentration of methane and nitrous oxide. So that is how the agriculture is coming into picture, agriculture and related activities coming into the picture as far as the climate change is concerned. Now, when you look at the overall statistics, the agriculture, forestry and other land use sector contributes about 10 to 12 gigatons of carbon dioxide equivalent per year. It's a significant amount, 10 to 12 gigatons out of 49 gigatons of carbon dioxide equivalent. So AFOLU, that is agriculture forest related activity, is also very significant from the perspective of mitigation. from the perspective of adaptation, because climate change can immensely affect the agriculture sector, because this agriculture sector is a climate sensitive sector. Many sectors are climate sensitive, but this sector, agriculture sector, is more climate sensitive, because every activity is dependent on the climate, is dependent on the climate variable, is dependent on the suitable environment that is existing in the, the crop environment, I mean. So that is very significant. Even a small change in the climate, that can cause a drastic effect on the yield, drastic effect on the agriculture production, and also animal, I'm talking about the livestock, animal husbandry activity also. So the greenhouse gases emission from the agriculture sector is mainly because of the land use changes. Also the the livestock I'm talking about the ruminant fermentations, and as I told you that the biomass and the crop residue burning or biofuel burning. And most important thing as far as our country is concerned, it is the lowland paddy cultivation. So these all things contributes. These all related agricultural activity contributes to the increase in greenhouse gases emissions. On account of land use and land cover changes like deforestation, I talked about it, the carbon dioxide is emitted into the atmosphere, and the atmospheric carbon dioxide, it is sequestered mainly because, again, it's a very important thing, because it is sequestered through land use activities such as what is that? Yes, afforestation and reforestation activity, because this is having a lot of mitigation potential, afforestation and reforestation activity, because we just talked about the deforestation, need to talk about the afforestation as well, so that the mitigation, or so that the atmospheric carbon dioxide concentration is slowly and steadily sequestered by the vegetation biomass through a natural process called photosynthesis. So the global net carbon dioxide emissions due to land use changes from the last century, it amounts to around 1.1 picogram of carbon. The increase in the atmospheric methane, as if you look at it, is mainly due to the anthropogenic emissions. Nevertheless, the source of carbon dioxide can be either a thermogenic or biogenic as well. So the thermogenic sources include mainly the natural emissions. I talked about it, natural emissions from the geological sources. On the other hand, the biogenic sources include the natural and anthropogenic sources, biogenic sources. So the anthropogenic biogenic sources also is due to the human activities, particularly I told about the paddy cultivation, lowland, particularly the lowland cultivation, and rearing of livestock. The livestock is also very significant, because the ruminants, because of the enteric fermentation, it releases the methane into the atmosphere, and also the anaerobic bodies and the even water bodies, that also a source of methane emission, because the organic matter present in the water bodies on decomposition can also release methane into the atmosphere. And as far as the ruminant is concerned, I told you that the cattle, the buffalo, and the sheep, goats, they are basically the ruminants, because the ruminants are very important group of animals, because for the livelihood they are important, for providing the food and nutrition security they are important. At the same time they are important because they are also responsible for releasing methane into the atmosphere, and that is how we need to manage through a lot of strategies, mitigation through the feed, rationing, or bringing in a lot of protein rich feed. Definitely we can reduce the methane emission from the ruminants. It's again a very important topic as far as the ruminant or enteric fermentation is concerned. So the increase as in the atmospheric concentration of nitrous oxide, if you look at it, the past 4-5 decades, is because of again the use of rampant use of synthetic nitrogenous fertilizers. Who can forget about the green revolution? Because the green revolution, or the increase in the agriculture productivity and production in our country, if we look at it in the past of 6-7 decades, it's mainly because of packager practices, and mainly because of highly fertilizer responsive varieties, crop varieties. So in a way, the fertilizers, the nitrogenous fertilizers, have played a very important role in green revolution, and this application of nitrogenous fertilizers also is having a lot of pitfalls. In fact, it is also responsible for causing climate change through the emission of nitrous oxide, which is a very important greenhouse gases. Okay. So now of course I just talked about the microbial processes like nitrification and denitrification. They are squarely responsible for increased atmospheric nitrous oxide concentration in the atmosphere. When you talk about the nitrification and when you talk about the denitrification process, I am just trying to give a thought for you, a food for thought indeed, because the nitrification and denitrification process are responsible for releasing nitrous oxide. By that what I mean to say is that why not have a strategy to minimize the process, the microbial mediated process like nitrification. Through nitrification inhibit us? Yes, it is possible. So we need to take into account those things also as part of the mitigation strategies. Okay. So now let us look at the take home message. Because when you talk about this particular session, I just introduced the topic of climate change, how important the climate change is, what are the drivers. So the message here is the climatic conditions are varying in nature, all along it is varying, it is not static. So since its formation, Earth's climate was changing due to natural drivers of climate change. However, the human activities in the post-industrialization era resulted in increase in the radiatively active gases in the atmosphere, leading to increase in the global mean surface temperature. At any given point of time, the Earth's climate is subjected to a number of influences. The drivers of climate change are both of natural reasons, natural origin, and also anthropogenic activity. The important natural drivers that we have discussed are the solar irradiance, the Milankovitch cycle, orbital variations, the tectonic processes, the volcanic eruptions, they are very natural processes. But as regards the anthropogenic drivers, we have seen mainly the changing atmospheric greenhouse gas composition, the atmospheric chemistry, and also the land use changes and the aerosol loading. The second important message from this session is that the atmosphere and the ocean are getting warmer. Every passing year it is getting warmer and warmer, and that can have a drastic effect on both the atmospheric circulation and ocean circulation as well. So the amount of snow, that is a significant thing, the amount of snow and ice also started declining, and sea level is fast increasing in the past century because of the changing climate. The last one is the climate change, what we are discussing about, it is threatening our existence. It can affect all the possible components of the biosphere. So with that, I'll conclude this session. In essence, we have seen in the session the climate system, the components of climate system, the natural and anthropogenic drivers of climate change, and also the trends of greenhouse gas emissions since the Industrial Revolution. So in the coming session, we will be having further discussion on different aspects of climate change. Thank you.